Hello, welcome to this new tutorial on Java. So we have been working on Java collections for the last few tutorials, and we have discussed about the list interface, we have discovered the set interface, and today we are going to talk about the map interface. So this is another interface in Java, in the Java collections library. So we're just going to talk about this map interface. So what this map is really, so this map is another kind of data structure which allows you to maintain the mappings between key and value. And let's say you want to store, let's say you have a list of error codes and you want to store the description. So let's say error code is 1. Let's say you have some description, item not found. I'm just trying to make it here. Error code 2, you want to say item out of stock, so on. So you have this unit, you have the key and you have the value. Sorry, you have the key here and there's a value this side, key value. So you could also do like same thing for like let's say key is 0, you say day of the week, 1 is Monday, 2 is Tuesday. So if you want to just store this key value pairs, you can use this map. And same with the we discussed in the previous video about the set, and there are different implementation classes for the set. For the map, the similar set of classes are also available for the map. So if you remember from the previous video, for the set we have has set, and for map we have is called HashMap. Then we have linked has map, and we also have TreeMap. And what's the difference between these three, or which one you should use for your specific need? So similar to the set, for the hash map, if you want to hash map, you can store key value pairs, and you don't really want to maintain the order. When you retrieve, they could store in any order in the map. So you can use hash map. But if you want to keep the order of insertion, let's say you add item 1, then add item 3, then 4, and you want to retrieve, then 1, 3, 4, they will come out in that order. So it will keep the order in place. It will maintain your order the way you inserted the items into that map. And there's a third one, is a tree map. So tree map is used when you really want to store the data in a sorted way, and the sorting is defined by the natural ordering of the elements which are stored in that key field actually. So we will see it with the help of an example. So let's say I'm going to continue the same kind of example I've been using. So let's say first let's do this map. So the map has two things. Earlier we were in the list, we were just storing just the item, and there was only one type here which said just string. So let's get this going here. So but in case of map, we have two types specified. First is the key and other is value. So let's say we call it, we still going with the same example cars, and we call it new as map, and this is also string. And let's try to import these values here. So util package, and everything is in the util package for the collection interface. So what we are really doing is, for the map, we said it takes kind of two arguments, if you want to say, or it has two types defined, and the first type is called key and the second one is called value. And this could be more complex. The value could be, instead of just a string, it could be another object. Like we could have an object called let's say we want to say I'm just trying to pick up an example of object is a person. This could be a object, and person could have its own attributes. It could have a person could have a name, height, profession, or whatever you want to put it there. So this could be more complex, not doesn't have to be just a string here. So but for this example, I'm just going to put here string. And the way to add stuff into this map is you have to use the put, and you see it if you see this constructor here says key and the value. So I'm going to say, let's say I still want to put some cars here, but let's say I'm putting some kind of code for the car, and F is for Ford. It's like I just put a code. F mean the description is Ford. So same thing, and let's do one more. H is for, let's say, Honda, and let's say this third one is T for Tesla. Yeah, so you can see what I am trying to define, and it could be totally different, whatever you want to put it here, key value here. So, and I'm going to just put all these values out here. Cars. So insertion order doesn't matter. So I don't know, maybe the Tesla could come first. Although we inserted Ford first, then we did Honda, then we Tesla. But let's see what gets printed, and it could be just totally random. Yeah, see, Tesla came first, Ford, Honda. Let me run one more time. Yeah, probably, it will be totally random, but right now it's kind of, looks very consistent. It does the Tesla first. So let's take another example of, now we're going to do the linked HashMap. And the linked HashMap, so let's try to get in this one here, and we can name this variable cars1 now, because we already use cars. So cars1. Okay, so let's clear this one out. So cars1, we put Ford first, we put Honda, we put Tesla, and when I print this one, this would be printed in the same order: Ford, Honda, Tesla. Let's see. Yeah, you see this one here, second one. This is the one we are talking here. Ford. It doesn't matter how many times you run. Ford, Honda, Tesla. Ford, Honda, Tesla. So it keeps the order. So if you want to keep those kind of ordering intact, you should use this one. So let's go to the third one. So third one is called TreeMap. So we have to get this from the util package too, and I want to call it cars2. And let's say Ford FGHI. So let's put the Tesla in the beginning, just to show you that how did it keep in the stuff sorted out actually. So so in the third one, we put Tesla first, Ford, and Honda. So what's the natural ordering? Because this is a tree map, so it will put everything in a sorted order. So Ford should be first, then Honda, then Tesla. So let's run it. Yeah, you see this third one, this is the one for sorting, tree map, Ford, Honda, Tesla. And let's run it one more time. Yeah, this will keep the order as it is. So let's say I want to add one more. Let's say at the end, I'm trying to just show you this. I want to say A for Audi. Now what will happen is Audi will show first. Oh, what happened here? So, oh, never mind. Actually, we were printing cars to cars. So I was printing the wrong. I was printing the previous one, but I'm printing now cars too. So let me just comment it out just to show you first the 3 only, then we can add the Audi. Oh yeah, so third one we just showed here. This one is Ford is first, then Honda, then Tesla. Although we put the Tesla first, but it came at the last because that's what T comes after F and H. So now we are going to add here Audi. So I added basically I added the 4 items to this cars too. So the A should come first, then Ford, then Honda, then Tesla. You see, A came first, Audi, Ford, Honda, and Tesla. So these are very helpful data structures down it. There's only a little bit difference between these two, and you have to just know what kind of situation you have, what kind of things your program requires, and based upon that one, you can make the best choice, and you should use that particular data structure. So I hope you like this video. Please consider subscribing to the channel and like the video, and I will see you in the next video with a different topic. Thank you. Bye.